Imagine, for a moment, that you are lying beneath a quiet night sky. The air is cool, and the world around you has grown still. Above you, countless stars shine with a patient light that has traveled across vast distances to reach your eyes. Some of that light began its journey long before the first cities were built, long before your ancestors ever looked upward and wondered about the heavens. And as you rest there, another quiet question drifts gently into your thoughts. What exactly is time? You feel it every day. You wake in the morning, watch the afternoon sunlight slide slowly across the floor, and eventually settle into the soft darkness of night. Hours pass, minutes move forward, and seconds tick steadily along like footsteps on a long road. For most of human history, time seemed simple. It was imagined as something steady and dependable, like a river flowing calmly through the landscape of existence. No matter where you stood along its banks, the water moved at the same gentle pace. A second here was the same as a second somewhere far away. A minute on Earth would be the same minute on a distant mountain or a ship crossing the sea. This idea feels comforting. It suggests that the universe keeps a single, perfect rhythm. Like a grand cosmic clock, quietly ticking in the background of reality. Long ago, people tried to measure this rhythm with the simplest tools they could imagine. They watched shadows move across the ground, creating the first sundials. They listened to the steady drip of water clocks. Later, delicate mechanical gears were crafted to count each passing moment with greater precision. Tick after tick, these clocks seemed to capture time itself, slicing it neatly into seconds and hours. But even as humans grew better at measuring time, the deeper nature of time itself remained mysterious. You might think of time as the invisible thread that stitches events together. Without it, nothing could unfold. A seed could never grow into a tree. A child could never become an adult. A star could never ignite in the darkness of space. Time is the quiet stage upon which every story is told. Yet there is something curious about it. Unlike space, you cannot turn around and walk backward through time. You cannot pause it in the air like a falling snowflake. Time moves forward, always forward, carrying every moment gently into the past. And for centuries, scientists believed this forward flow was perfectly uniform. Perhaps you can imagine a vast universal clock somewhere beyond the stars. No matter where you travel in the universe, that clock ticks at exactly the same pace. 1 second, then another, and another. Always steady. Always the same. This was the vision described by the great physicist Isaac Newton in the 17th century. Newton imagined time as something absolute. In his view, time flowed independently of everything else. It did not care about motion, distance, or gravity. Whether a person stood still or raced across the ocean, time continued onward at its calm, unchanging pace. And for many years, this idea worked beautifully. It explained the motion of planets. It described falling apples and orbiting moons. It allowed scientists to calculate the paths of comets moving silently through the night sky. The universe, according to this picture, was a beautifully ordered machine. Space was the stage. Time was the ticking clock. And matter moved predictably within it all. Yet nature often hides deeper layers beneath simple ideas. If you watch the stars carefully enough, or measure motion with enough precision, the universe begins to whisper small inconsistencies. tiny hints that reality may be more flexible than it first appears. Imagine again that river of time. For centuries, it seemed to flow smoothly everywhere. But what if, in certain places, the current moved just a little more slowly? What if somewhere in the universe the water stretched and lingered before continuing onward? At first, such a thought would have sounded impossible. How could time change its pace? After all, clocks seemed so reliable. Build two identical clocks, place them side by side, and they tick together in perfect harmony. Tick, tick, tick. But the deeper scientists looked into the nature of light, motion, and the structure of space itself, the more mysterious things began to feel. The universe, it seemed, might not operate on a single cosmic clock after all. Perhaps time was not a rigid river. Perhaps it was something softer, something more flexible, like a fabric that could stretch, or a melody that could slow and drift under certain conditions. At this stage in our story, these ideas are only faint hints, gentle ripples across the surface of understanding. No one yet fully sees how dramatic the truth might be. But somewhere in the early 20th century, in a quiet office filled with papers and ink and patient thinking, a young mind begins to imagine something extraordinary. He is not surrounded by grand observatories or enormous machines. Instead, he sits at a desk reviewing patents, examining the designs of clocks and electrical devices. And as he studies these inventions, his thoughts wander toward a strange question. What would happen if you could chase a beam of light? What would time look like then? It is a small thought at first, just a quiet spark of curiosity. Yet that spark will slowly grow into one of the most profound discoveries in the history of science. Because hidden within that simple question lies a revelation that will transform our understanding of reality itself. A realization that time does not flow the same everywhere. That motion can stretch it. That gravity can slow it. And that the universe keeps time in ways far stranger than anyone had imagined. But for now, the idea remains only a whisper. A gentle thought drifting through the mind of a young patent clerk, wondering what might happen if time itself could bend. Imagine a quiet office in the early years of the 20th century. The room is modest. Papers rest in small stacks across a wooden desk. The faint scratching of a pen fills the calm air, and sunlight filters softly through the window. Outside, the city moves through its ordinary rhythm. People walk along cobblestone streets. Carriages roll slowly past. Inside this peaceful room sits a young man working at the Swiss patent office in the city of Bern. His name is Albert Einstein. At first glance, nothing about this moment appears extraordinary. Einstein's job is not to study stars or planets. He does not work in a grand observatory surrounded by telescopes and instruments. Instead, his task is to examine applications for new inventions. Many of these inventions involve clocks. Clocks that must stay synchronized across long distances. Clocks used for railway systems. Electrical devices designed to measure precise moments in time. So day after day, Einstein studies these designs carefully. He reads technical descriptions and diagrams. He considers whether the ideas are new, useful, and truly original. But while his eyes follow the neat lines of each patent document, his mind drifts somewhere else. Quietly, gently, he begins asking deeper questions. What does it really mean for two clocks to show the same time? If two clocks sit side by side in a room, their ticking is easy to compare. But what if one clock is placed on a train rushing across the countryside, and another remains still in the station? Would their ticking remain perfectly synchronized? At first, the answer seems obvious. Of course they would. Time, as most people believe, flows the same everywhere. Whether you stand still or travel quickly, a second is always a second. Yet Einstein begins to wonder, what if this assumption hides a deeper mystery? To explore the question, he imagines something simple: a long train moving smoothly along a track. You can picture yourself standing on a quiet platform beside the railway. The train glides past you with steady motion, its windows reflecting the soft light of the afternoon sun. Now imagine two bolts of lightning striking the train. One strikes the front of the train. The other strikes the back. To you, standing on the platform, the flashes appear at exactly the same moment. The light from both strikes reaches your eyes simultaneously. You would naturally say that the two lightning bolts happened at the same time. But now imagine someone sitting inside the train, exactly in the middle of one of the carriages. From their perspective, something different happens. Because the train is moving forward, the passenger moves toward the flash from the front of the train. At the same time, they move away from the flash from the back. Light, however, always travels at the same speed. So the flash from the front reaches the passenger slightly earlier. The flash from the back arrives a moment later. To the passenger, the lightning strikes do not seem simultaneous at all. One appears to happen before the other. The same two events. Two observers. Two different answers about when they occurred. This simple thought experiment reveals something deeply surprising. Time may not be as universal as people once believed. Events that seem simultaneous to one observer might not be simultaneous to another who is moving differently. The idea is quiet, but powerful. It suggests that time itself may depend on perspective. You might think of time like the rhythm of music drifting through a room. If you stand still, you hear the melody in one steady way. But if you begin moving quickly through the space, the rhythm shifts slightly. Notes stretch. Moments slide past each other. The melody changes, even though the music itself remains the same. Einstein's mind returns again and again to another strange fact about the universe. Light always travels at the same speed. No matter how fast you move, light still rushes past you at exactly the same cosmic pace, about 300,000 kilometers per second. This rule had already been discovered through careful experiments. Yet it carried a hidden consequence that few people fully understood. If light's speed is always the same, something else must adjust to make that possible. And that something, Einstein realized, is time. To keep the speed of light constant for all observers, the universe quietly reshapes the flow of time itself. Clocks moving through space do not tick exactly the same way as clocks at rest. Motion, it seems, gently stretches time. At first this idea feels almost impossible. After all, time seems so steady in everyday life. Your watch ticks calmly on your wrist. The sun rises and sets with familiar rhythm. But the universe operates on scales far beyond everyday experience. At very high speeds approaching the speed of light, the stretching of time becomes noticeable. A moving clock ticks more slowly than a stationary one. Not because the clock is broken, not because the mechanism fails, but because time itself flows differently for objects in motion. This realization becomes the foundation of a revolutionary idea known as special relativity. Published in 1905, Einstein's theory gently reshapes our understanding of space and time. No longer are they separate, rigid elements of reality. Instead, time becomes something flexible, something connected to motion. The faster you move, the more time stretches. The universe, once imagined as a perfectly synchronized machine, now begins to resemble something more fluid. Something dynamic. Something almost alive. Yet at this moment in our journey, the idea is still only beginning to unfold. Einstein himself often describes his thinking not as complicated mathematics, but as simple imagination. He calls them thought experiments. Quiet mental journeys where you picture trains, clocks, and beams of light moving through space. And among these gentle experiments, one question continues to echo in his mind. What would happen if you could travel alongside a beam of light itself? If you could keep pace with light as it raced across the universe, what would you see? How would time behave then? The question floats softly in the air, like a small lantern drifting upward into the night. And as you follow that lantern with your thoughts, the next step of the journey begins. Because to truly understand how time bends, you must imagine something extraordinary. Imagine standing quietly on the surface of Earth. The ground beneath your feet feels steady and familiar. The sky stretches overhead in a calm blue arc, and somewhere in the distance an airplane leaves a thin white trail across the atmosphere. Everything feels stable. Clocks tick calmly. Minutes pass at their comfortable, predictable pace. Yet far beyond the clouds, motion begins to tell a slightly different story. The universe is never truly still. Planets spin. Stars orbit the centers of galaxies. Entire galaxies drift slowly through the vast cosmic ocean. And whenever something moves, time responds. Not dramatically at first. The changes are subtle, almost invisible. But they are real. You might imagine time as a soft current flowing through the universe. When you stand still, the current carries you forward at a steady pace. But when you begin moving through space, especially very quickly, that current shifts slightly around you. It slows. The faster you travel, the gentler the current of time becomes. This quiet phenomenon is part of the strange beauty of special relativity, first described by Albert Einstein. The idea may sound surprising, but its roots are simple. Nothing in the universe can move faster than light. The speed of light acts like a cosmic limit, a boundary written into the structure of reality itself. To preserve that limit, the universe must adjust something when objects move extremely fast. And what it adjusts is time. Imagine now that you are no longer standing on Earth. Instead, you are sitting quietly inside a spacecraft. Outside the window stretches a dark ocean of stars. The engines hum softly, and slowly the craft begins to accelerate. At first the motion is gentle, barely noticeable. But soon the spacecraft moves faster than any airplane. Then faster than any rocket humans have ever built. Faster and faster still. As the spacecraft approaches incredible speeds, something subtle begins to happen. From the perspective of someone watching from Earth, the clock inside your spacecraft starts ticking more slowly. Not because the clock is broken, not because its gears are damaged, but because time itself flows differently for objects moving at such tremendous speed. Each second inside the spacecraft becomes slightly longer compared to the seconds passing on Earth. Tick. Pause. Tick. The faster the spacecraft travels, the longer those pauses grow. Inside the ship, however, everything feels perfectly normal. You breathe calmly. Your heart beats steadily. Your own watch ticks with familiar rhythm. From your perspective, time has not changed at all. This is one of the most fascinating aspects of relativity. Time does not slow down in an absolute sense. Instead, it slows relative to other observers. Someone standing still sees your clock ticking more slowly. Meanwhile, you feel as though their clocks are the ones behaving strangely. It is as if each traveler carries their own personal river of time. Most of the time these rivers flow together smoothly, moving side by side without noticeable differences. But when motion becomes extreme, the rivers begin to drift apart. One current flows slightly slower than another. And so two travelers who begin their journeys together may not experience exactly the same number of moments. You might picture two friends standing beside each other at the beginning of a long road. One friend stays behind. The other boards a spacecraft and travels across the stars at tremendous speed. From the perspective of the friend on Earth, the traveler's clock ticks more slowly during the journey. Their life unfolds at a slightly gentler pace. Their moments stretch just a little longer. When the traveler eventually returns, something surprising has happened. More time has passed on Earth than inside the spacecraft. The traveler has experienced fewer seconds, fewer minutes, fewer years. In a sense, they have aged more slowly. This is not science fiction. It is a real and measurable consequence of the universe's structure. Even here on Earth, small versions of this effect have been observed. Tiny particles moving close to the speed of light survive longer than they normally would because time for them is stretched. Their internal clocks slow down as they race through space. These experiments confirm the strange predictions of relativity with remarkable precision. And so motion reveals something profound about the nature of time. Time is not rigid. It is flexible. Like a soft thread woven through the universe, it can stretch when pulled by extreme speed. Yet motion is only one way this stretching can occur. There is another force in the universe capable of bending time even more dramatically. You feel this force every day without thinking about it. It pulls gently at your body. It keeps your feet anchored to the ground. It guides the moon in its quiet dance around Earth and holds the planets in their slow circles around the sun. Gravity. At first, gravity seems simple, just a pull between objects with mass. But hidden within that pull lies another remarkable secret. Gravity can slow time too. Not because objects are moving fast, but because space itself becomes curved and deep around massive objects. The deeper you move into this gravitational landscape, the slower time flows. It is as if time sinks into the valleys of gravity. Near massive worlds, moments stretch slightly longer. Clocks tick more slowly. The deeper the valley, the slower the river of time becomes. For now, this idea may feel distant, like a landscape glimpsed through mist. But soon we will step closer to it. Because to truly understand how gravity bends time, you must first imagine the universe in a completely new way. Not as empty space with objects floating inside it, but as something softer, something woven together. A vast, invisible fabric where space and time are joined as one. And somewhere in that gentle cosmic fabric, gravity quietly shapes the rhythm of every ticking clock. Imagine again that you are standing quietly on Earth. The ground beneath you feels steady and reassuring. The air moves gently across your skin, and somewhere nearby a clock ticks with a calm, familiar rhythm. Tick, tick, tick. Each second passes with quiet certainty, and it feels as though this rhythm must be the same everywhere. Time appears steady, dependable, almost like the slow breathing of the universe itself. But far beyond the quiet fields and cities of Earth, motion begins to tell a different story. The universe is full of movement. Planets spin on their axes. Moons circle their planets in patient loops. Stars orbit the centers of galaxies, completing journeys that take hundreds of millions of years. Nothing is truly still. And according to the ideas revealed by special relativity, motion quietly reshapes the flow of time. To understand this, imagine that you step aboard a spacecraft. The cabin is peaceful, softly lit. Outside the window, the vast darkness of space stretches endlessly in every direction. Distant stars glow like scattered lanterns. At first, the spacecraft begins to move slowly. You drift gently away from Earth, leaving the atmosphere behind. The blue planet grows smaller beneath you, fading into a soft marble floating in the blackness. The engines hum quietly, and the ship accelerates. Soon you are moving faster than any airplane. Faster than any rocket that has ever carried humans into orbit. Still faster. Faster than anything humans have ever built. Yet inside the spacecraft, everything feels calm and ordinary. Your breathing is steady. Your heartbeat keeps its familiar rhythm. And the clock beside your seat continues to tick. 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 But from far away, something subtle has begun to change. An observer watching your spacecraft from Earth would notice something unusual about that clock. Its ticking appears slower. Not dramatically slower at first. Just slightly delayed, as though each second is stretching very gently. This strange effect happens because of one simple rule written into the structure of the universe: nothing can move faster than the speed of light. Light travels through space at about 300,000 kilometers each second. This speed is not just very fast, it is the ultimate speed limit of reality. No object can exceed it. And in order to preserve this rule, the universe quietly adjusts something when objects move extremely quickly. That adjustment happens in time itself. The faster you travel, the more slowly time flows for you compared with someone who remains still. This phenomenon is known as time dilation. The phrase may sound technical, but the idea is beautifully simple. Time stretches when you move very fast. You might imagine time as a soft thread connecting moments together. Most of the time, the thread feels perfectly steady. Seconds pass with their familiar rhythm. But when motion becomes extreme, that thread begins to stretch. Moments grow slightly longer. Clocks tick more slowly. Inside your spacecraft, however, you notice nothing unusual. Your watch continues its calm rhythm. Your thoughts drift quietly from one moment to the next. From your perspective, time feels completely normal. This is one of the most fascinating features of relativity. Time does not slow in an absolute way. Instead, it slows relative to other observers. Someone standing on Earth sees your clock ticking more slowly. Meanwhile, you might see their clocks behaving strangely compared with yours. It is almost as though every traveler carries their own personal stream of time. Most of the time these streams flow together peacefully, like gentle rivers running side by side. But when someone begins moving incredibly fast, their river of time begins to drift away from the others. Its current slows. Its moments stretch. Imagine now two friends beginning a journey together. They stand side by side beneath the same sky, their watches synchronized to the same second. One friend stays behind on Earth. The other boards the spacecraft and travels across the stars at tremendous speed. Days pass. Months pass. Years pass. From the perspective of the friend on Earth, the traveler's clock moves more slowly throughout the journey. Each tick takes slightly longer than the ticks of clocks on the ground. When the traveler finally returns home, something curious has happened. The friend who remained on Earth has experienced more time. More days. More birthdays. More quiet moments beneath the sky. The traveler, however, has experienced fewer of those moments. They have aged a little less. Their journey through time has been slightly shorter. This idea might sound like a story from imagination, but scientists have carefully tested it. Experiments with tiny particles moving near the speed of light show that their internal processes slow down exactly as relativity predicts. Even highly precise clocks carried aboard fast-moving aircraft have shown tiny differences compared with clocks left on the ground. These differences are small, but they are real. They confirm that motion gently stretches time itself. The faster you move, the more dramatic the stretching becomes. At everyday speeds, the effect is far too small for humans to notice. Cars, airplanes, and even rockets move slowly compared with the speed of light. But as objects approach the cosmic limit, time begins to stretch more and more. Moments lengthen. Clocks slow. The universe quietly reshapes the rhythm of time. And yet, motion is not the only force capable of bending time. There is another influence in the universe that can stretch time even more powerfully. You feel this influence every day. It pulls gently at your body. It holds oceans against the surface of Earth and keeps the moon moving in its patient orbit. It shapes the paths of planets and binds galaxies together. Gravity. For centuries, gravity was understood simply as a force pulling objects toward one another. But hidden within gravity is another extraordinary secret. Gravity can slow time too. Not because objects are moving quickly, but because the very structure of space itself becomes curved and deep around massive objects. The deeper you move into that gravitational landscape, the slower time begins to flow. It is as if time sinks into the valleys created by gravity. Near massive worlds, clocks tick a little more slowly. Moments stretch. Seconds linger slightly longer before drifting away. Imagine two twins standing side by side beneath a calm evening sky. They share the same birthday. They have grown together through the same childhood moments, the same quiet mornings, the same familiar rhythm of days passing into years. Their watches tick together. Tick, tick, tick. At this moment, their lives unfold in perfect synchrony, like two melodies playing in harmony. But soon their paths begin to diverge. One twin remains on Earth. Their life continues within the steady rhythm of the planet, the rising of the sun, the passing seasons, the gentle turning of years. The other twin prepares for a journey. A spacecraft waits on a quiet launch platform. Its engines hold the power to carry a traveler far beyond the familiar neighborhoods of Earth and deep into the wide silence of space. The traveling twin steps aboard. With a soft roar of engines, the spacecraft rises slowly into the sky. Earth grows smaller below, shrinking into a blue sphere floating peacefully in darkness. Soon the ship begins to accelerate. Faster than airplanes. Faster than rockets. Faster and faster still, until it moves at speeds approaching the cosmic boundaries set by the speed of light. Inside the spacecraft, everything feels normal. The traveler floats gently in the quiet cabin. Their breathing is calm. Their heart beats with its familiar rhythm. A clock on the wall ticks steadily. Tick, tick, tick. From the traveler's perspective, nothing unusual has happened to time. Days pass. Meals are eaten. Thoughts drift quietly through long hours of silent travel. But far away on Earth, something subtle is unfolding. According to the strange and beautiful rules of special relativity, time flows differently for objects moving at such tremendous speeds. The faster something travels through space, the slower time flows for it compared with observers who remain still. This gentle stretching of time is known as time dilation. From Earth's perspective, the clock inside the spacecraft ticks more slowly. Each second inside the ship lasts slightly longer than a second on Earth. Tick. Pause. Tick. The traveler is still living through moments, but those moments are unfolding more slowly relative to the world they left behind. Years pass on Earth. The twin who stayed behind continues their life beneath the familiar sky. Seasons change. Trees grow taller. Cities shift and evolve. Meanwhile, the traveler crosses immense distances between stars. From their perspective, only a few years may pass. Inside the spacecraft, time flows gently and calmly. But outside, the rest of the universe moves ahead more quickly. Eventually, the traveler turns the spacecraft around and begins the long journey home. Again the ship accelerates to enormous speed, gliding through the darkness between stars. Eventually Earth appears again, a small blue sphere growing larger in the window. The traveler returns. The spacecraft descends through the atmosphere and lands quietly. Two twins meet again. But something remarkable has happened. The twin who remained on Earth has aged more. More years have passed for them. More birthdays have come and gone. More quiet mornings have unfolded beneath the sky. The traveler, however, has experienced fewer of those moments. Their journey through time has been shorter. They are younger than their sibling. This thought experiment is known as the twin paradox. At first it seems puzzling. How can two people begin together and reunite with different ages? But the answer lies in the deep structure of space and time. Motion changes the rhythm of time itself. The twin who remained on Earth stayed within one steady flow of time. The traveler moved through space at extraordinary speed, and that motion stretched time along their path. You might imagine time as a long river flowing quietly through the universe. Most of the time we drift together along its current. But when someone begins moving extremely fast, their path through the river changes. Their current slows. They travel a slightly shorter distance through time. And so when they return, fewer moments have passed for them. What once seemed like an abstract scientific idea becomes something personal and human. A journey through space becomes a journey through time. Scientists have tested these ideas carefully. Highly accurate clocks carried on fast-moving airplanes have shown tiny differences compared with clocks left on Earth. Particles traveling near the speed of light survive longer than expected because time slows for them. Again and again, experiments confirm what relativity predicts. The universe truly allows motion to reshape time. Yet this is only one part of the story. Speed can stretch time. But there is another influence in the cosmos that can bend time even more powerfully. You feel it every day without thinking. It pulls gently at your body. It anchors oceans to the surface of Earth. It guides the moon through its slow, graceful orbit. Gravity. At first glance, gravity seems simple, just a force pulling objects toward one another. But hidden within gravity is another quiet mystery. Gravity does more than pull. It also slows time. Near massive objects, clocks tick more slowly. Seconds stretch slightly longer. The deeper you move into the presence of gravity, the more gently time flows. This discovery would eventually lead Einstein beyond special relativity into an even deeper understanding of the universe. An understanding where space and time themselves become curved and flexible. Where gravity is not simply a force, but a bending of the very fabric of reality. And as your thoughts drift toward that idea, you begin to sense that the story of time is about to deepen even further. Because somewhere in the silent depths of the cosmos, gravity is quietly shaping the rhythm of every ticking clock. Imagine standing quietly on the surface of Earth once more. Your feet rest firmly on the ground. The air presses softly around you, and the familiar pull of gravity holds you gently in place. You rarely notice this force. It feels so ordinary, so constant, that it becomes almost invisible to your awareness. Yet gravity is always there, quietly guiding the motion of everything around you. A falling leaf drifts toward the ground. Rain descends from clouds. The moon circles Earth in a patient, silent orbit. Gravity shapes all of these movements with quiet consistency. For centuries, gravity was understood simply as a force pulling objects toward one another. The English scientist Isaac Newton imagined gravity as an invisible attraction between masses. In this view, Earth pulls on the moon. The sun pulls on the planets. And every object with mass pulls gently on every other object. This explanation worked beautifully for many situations. It allowed scientists to predict the motions of planets and the paths of comets with remarkable precision. But as the understanding of the universe deepened, another layer of truth began to emerge. Gravity was not just a force. It was something more subtle. something woven into the structure of space and time itself. This deeper insight came from the quiet imagination of Albert Einstein. Einstein realized that gravity could also influence the passage of time. Not dramatically in everyday life, but gently, almost imperceptibly. Clocks placed near massive objects tick slightly more slowly than clocks far away from them. This phenomenon is known as gravitational time dilation. The idea may feel strange at first. How could gravity affect time? To understand it, imagine time as a river flowing through the universe. In empty space, far from stars or planets, that river flows smoothly and freely. Seconds pass with their usual rhythm. But when the river approaches a massive object, a planet, a star, or something even heavier, the landscape begins to change. Gravity creates a kind of valley in the flow of space-time. The river slows slightly as it passes through this deeper region. Moments stretch just a little longer. Time flows more slowly there. Imagine now two identical clocks. One clock sits here on Earth, resting quietly on a table. The other clock is carried far away into deep space, where the influence of Earth's gravity is weaker. If you could compare them very carefully, you would notice something subtle. The clock on Earth ticks slightly more slowly. Not enough for you to notice with ordinary senses. But with extremely precise instruments, scientists can measure the difference. Gravity gently slows the passage of time. The stronger the gravity, the slower time flows. You might imagine space-time as a vast landscape of hills and valleys. Massive objects create deep valleys in this landscape. Planets create shallow ones. Stars create deeper ones. And extremely dense objects, such as black holes, create valleys so steep that time slows dramatically near them. But here on Earth, the valley is gentle. Time flows only a tiny bit more slowly at the surface than it does far away in space. Even a small change in height can affect the rhythm of time. A clock placed on a mountain will tick slightly faster than a clock placed at sea level. Why? Because the clock on the mountain sits a little farther from Earth's gravitational pull. It rests higher in the valley, where the flow of time is slightly quicker. These differences are incredibly small. But they are real. And modern technology is precise enough to detect them. Scientists have measured these effects using highly accurate atomic clocks, confirming again and again that gravity truly bends the flow of time. This discovery transformed our understanding of the universe. Time is not separate from space. They are woven together into a single structure called space-time. Mass and energy shape that structure, creating curves and valleys within it. And as space-time bends, the flow of time itself changes. In regions of stronger gravity, time moves more slowly. In regions of weaker gravity, time moves more freely. You might picture this like walking through a landscape. When the ground is flat, you move easily and quickly. But when you descend into a deep valley, your steps slow. Gravity reshapes the path you walk. In the same way, massive objects reshape the path that time itself follows. And so the universe becomes something far more elegant than anyone once imagined. Not a rigid stage where events simply unfold, but a living structure, flexible and responsive. Stars bend space-time around themselves. Planets carve gentle dips in the cosmic landscape. Galaxies shape enormous curves across millions of light years. Every massive object leaves its mark on the fabric of reality. And time flows differently through each of these regions. Yet even this is only the beginning of the story. Because to truly understand gravity's influence on time, you must imagine space-time itself as something tangible. Not an abstract idea, but a kind of fabric stretching across the universe. A fabric that can bend, curve, and ripple under the weight of massive objects. Once you begin to picture space-time this way, gravity becomes easier to understand. Objects do not simply pull on one another through empty space. Instead, they follow the curves created in the fabric of space-time. Planets follow curved paths around stars. Moons follow curved paths around planets. Even light bends when it passes near massive objects, tracing the subtle curves of space-time itself. And wherever those curves grow deeper, time flows more slowly. The deeper the curve, the gentler the ticking of clocks. This realization opened an entirely new chapter in our understanding of the cosmos. Gravity was no longer just a force. It was the shape of space-time itself. And as your thoughts drift across this vast cosmic landscape, you begin to sense that space and time are not separate threads. They are woven together. A single fabric stretching across the universe. A fabric that bends beneath the weight of stars. A fabric where gravity quietly reshapes the rhythm of time. And in the next part of this journey, you will begin to see that fabric more clearly, the gentle structure scientists call space-time. Imagine the universe as something soft. Not empty. Not rigid. But something gently stretched across unimaginable distances. For centuries, people imagined space as a vast, invisible container, a stage upon which planets, stars, and galaxies moved like actors in a grand play. Time, in this old picture, was something separate. It flowed steadily forward like the ticking of a perfect cosmic clock. But slowly, through careful thought and observation, scientists began to realize that the universe is not built this way at all. Space and time are not separate things. They are woven together. This idea lies at the heart of general relativity, the theory developed by the physicist Albert Einstein in the early 20th century. Einstein realized that space and time form a single structure, something we now call space-time. To understand this, imagine a large, smooth sheet stretched out in every direction. This sheet represents space-time. Every point on it corresponds to a location in the universe and a moment in time. Normally, the sheet lies calm and smooth. But when a heavy object is placed upon it, something interesting happens. The sheet bends. It dips downward under the object's weight, creating a gentle curve. If you roll a small marble across the sheet, its path will bend toward that curve. It is not being pulled directly by the object. Instead, it is simply following the shape of the surface beneath it. This simple image helps us understand gravity in a new way. Massive objects, planets, stars, galaxies, bend the fabric of space-time around them. And other objects move along the curves that this bending creates. What we feel as gravity is simply the result of following those curves. Earth does not pull the moon with an invisible force. Instead, Earth bends space-time around itself. The moon travels along the curved path, circling our planet in its quiet monthly dance. The same thing happens on a much larger scale throughout the cosmos. The sun bends space-time, guiding the planets along their gentle orbital paths. Galaxies bend space-time across millions of light-years, shaping the motions of countless stars. Even beams of light follow these curves. When light passes near a massive object, its path bends slightly as it moves through the curved fabric of space-time. This phenomenon, known as gravitational lensing, has been observed many times by astronomers studying distant galaxies. Light from faraway stars sometimes arrives at Earth after traveling along curved paths around massive clusters of galaxies. The universe itself acts like a giant lens, gently bending light across cosmic distances. But perhaps the most fascinating part of this picture is what it tells us about time. Remember the valleys created by gravity. Those valleys are not only shapes in space, they are shapes in space-time. When space-time curves, both space and time are affected together. The deeper the curve, the slower time flows. You might imagine space-time as a vast landscape. Massive objects carve valleys into this landscape. Near the top of a valley, time flows a little faster. Deep within the valley, time flows more slowly. This is why clocks on Earth tick slightly more slowly than clocks far away in deep space. Earth sits within a small valley in the fabric of space-time. And because of that gentle curve, time here moves just a little more slowly. The deeper the valley becomes, the stronger this effect grows. Near very massive objects, neutron stars or black holes, the valleys of spacetime become incredibly steep. There, time slows dramatically. But here on Earth, the curve is gentle. So gentle that you never notice the difference in everyday life. Your clock ticks calmly. Seconds pass quietly. Yet beneath this calm surface, the fabric of space-time is always shaping the rhythm of time. This realization changes the way we see the universe. Instead of imagining gravity as a force reaching invisibly across space, we begin to see it as geometry. The geometry of space-time itself. Planets follow curved paths because space-time is curved. Light bends because space-time is curved. Time slows because space-time is curved. The entire cosmos becomes a graceful dance within this flexible fabric. And this fabric is not static. It can stretch. It can ripple. When massive objects move suddenly, they create gentle waves that travel through space-time itself. These waves are known as gravitational waves. For billions of years, such waves have moved silently through the universe. They are created when massive objects, like merging black holes or colliding neutron stars, disturb the fabric of space-time. The ripples spread outward like waves across a cosmic ocean. Only recently have scientists developed instruments sensitive enough to detect these waves. In 2015, the observatory known as LIGO recorded the first direct detection of gravitational waves, confirming another remarkable prediction of Einstein's theory. In that moment, humanity was able to sense the subtle vibrations of space-time itself. The universe revealed yet another layer of its quiet beauty. And as you imagine this immense cosmic fabric stretching across galaxies, bending around stars, and rippling with invisible waves, the universe begins to feel different. Less mechanical. More fluid. More alive with motion and structure. Space and time are no longer rigid containers. They are threads woven together into the architecture of reality. Every star bends them. Every planet shapes them. Every moment unfolds within their gentle curves. And somewhere much closer to home, this bending of time is quietly helping guide the technology that navigates the modern world. High above Earth, satellites circle the planet. Their clocks tick differently from the clocks on the ground. And without correcting for those tiny differences, a system we rely on every day would slowly lose its accuracy. Because even here, in our everyday lives, the bending of space-time is quietly at work. Imagine standing beneath the wide, open sky, feeling the calm rhythm of seconds passing. Tick, tick, tick. Your watch counts the moments steadily, and the world around you moves at its familiar pace. But far above, a different rhythm quietly unfolds. High above the atmosphere, hundreds of satellites orbit Earth. They glide silently through the thin air, moving at thousands of kilometers per hour, circling the planet with precision that is almost unimaginable. Inside each satellite, clocks tick steadily. They measure time with remarkable accuracy, far beyond the precision of ordinary watches. Yet these clocks do not experience time in exactly the same way as clocks on the surface of the Earth. Because the satellites are moving so quickly, time for them flows a little more slowly than for someone standing below. This is the same quiet effect you explored in the story of the traveling twin. Motion bends time, even at the speed of orbiting satellites. But that is not the only factor. Gravity, too, plays a subtle role. Higher above Earth, the pull of gravity is slightly weaker. The satellites float in a gentle gravitational valley, far above the denser curve of space-time at Earth's surface. And because gravity slows time, clocks on the ground tick a tiny bit more slowly than clocks in orbit. The two effects, motion and gravity, pull in opposite directions. The high speed of the satellites tends to slow their clocks, while the weaker gravity tends to make them tick slightly faster. When scientists calculate both effects together, they find that the satellite clocks tick a little faster than clocks on Earth by about 38 microseconds each day. It is a tiny difference, just a fraction of a second. But even such a small difference would accumulate over time. Without correction, the satellite's navigation signals would become inaccurate by several kilometers each day. Imagine trying to find a quiet street in a bustling city, but your map is off by miles because time has been bending quietly above your head. To prevent this, scientists adjust the satellite clocks to account for both motion and gravity. They correct the tiny changes, keeping the system precise and reliable. This is the foundation of the Global Positioning System, GPS, the network of satellites that guides everything from cars to planes to ships. Time, once thought to flow steadily and uniformly, is carefully accounted for in these high-tech instruments. Relativity is no longer just an abstract idea in physics books. It is a rhythm woven into the tools that help people move across the Earth every day. The satellites orbit quietly, following their invisible paths through the curves of space-time. They carry with them clocks that tick ever so slightly differently than our own. And as you think about this, you might begin to see the universe in a new way. Even the smallest, most familiar moments are part of a larger cosmic dance. Time bends and stretches around massive objects, flows differently for moving travelers, and yet remains predictable enough that we can build systems to navigate the world. It is a delicate balance. A quiet interplay between motion, gravity, and the very nature of time. And yet, for all its precision, there is still wonder in the way it unfolds. Consider the travelers in orbit. They move silently through space, circling Earth thousands of times faster than your own steps on the ground. For them, seconds flow differently. For you, seconds feel steady. And yet, both experiences are true. The universe allows multiple rhythms to coexist, each shaped by motion, gravity, and perspective. This realization invites you to slow down, to notice the subtle ways the cosmos shapes everyday life. The next time you check a map, follow directions, or simply look up at the night sky, you can imagine the satellites above, ticking along their slightly altered course through time. Every signal they send is a message not just across space, but across the gentle curves of space-time itself. Even here, on our familiar Earth, relativity whispers its quiet truth: the universe is not rigid. Time is a flexible thread, and every movement, every gravitational pull, gently reshapes it. And as you rest beneath the sky, you can feel the rhythm of those invisible clocks, orbiting silently, guiding the world with a precision born from the soft bending of time itself. In this way, the cosmic rules of motion and gravity are not distant, abstract concepts. They are part of the quiet architecture of your daily life. They connect the most profound truths of the universe to the simplest acts of movement, navigation, and observation. And as you begin to imagine venturing farther, beyond Earth's orbit, you sense that time itself will bend even more dramatically. Around planets, near stars, and approaching the most extreme objects in the cosmos, gravity will slow the ticking of clocks in ways that surpass anything we have experienced here. Somewhere, in the depths of space, a black hole waits. And as you imagine drifting closer, the gentle bending of time by motion and gravity becomes even more extraordinary. Imagine floating in the quiet of deep space. The stars stretch endlessly in every direction, pinpricks of light scattered across a dark canvas. You drift calmly, feeling weightless, suspended in a universe that seems still yet full of hidden motion. Far below, a strange, dense region of darkness captures your attention, a black hole, invisible in its center, but announced by the way nearby stars swirl gently around it. Its presence is undeniable, a region where the usual rules of the cosmos begin to bend in ways that are almost unimaginable. You approach slowly, keeping a careful distance. The gravitational pull grows stronger as you drift nearer, not violently, but with a quiet insistence that wraps around you like an invisible hand. In this region, time itself begins to change. You remember the gentle stretching of time experienced by fast-moving spacecraft or by satellites orbiting Earth. Here, near a black hole, the effect is far more dramatic. Time slows almost to a standstill. Imagine an astronaut drifting toward the black hole. From your vantage point far away, you see their movements become slower and slower. Tick. Pause. Tick. Seconds stretch into minutes. Minutes into hours. The simple act of moving toward the black hole appears to take an eternity. The closer they get to the event horizon, the invisible boundary around the black hole, the slower their motion appears to unfold. Eventually, from your perspective, the astronaut seems frozen in time, suspended on the edge of eternity. Yet for the astronaut, the experience feels different. They feel themselves moving normally, their heartbeat steady, their thoughts drifting calmly. Time for them flows as it always has. It is only relative to your distant perspective that the moments stretch and slow. This is the ultimate expression of gravitational time dilation. Gravity here is so extreme that the very fabric of space-time curves sharply inward. A valley so steep that time near the center behaves almost differently from time far away. Light escaping the black hole struggles to climb out of this deep gravitational well. The signals take longer and longer to reach distant observers, carrying a delayed echo of events that are unfolding normally from the inside. You can imagine the light from the falling astronauts stretching, their image becoming redder and dimmer, fading slowly as if the universe itself is drawing out the moments. The gravitational pull grows with distance, tugging gently at the threads of time around the black hole. Even space seems to twist in the process, bending light paths and curving the trajectories of nearby stars. For nearby observers, physics begins to feel like a gentle distortion of familiar rules. Time stretches. Space curves. Moments become elongated, a quiet reflection of the extraordinary mass concentrated in a region so small it defies imagination. You begin to realize that the universe is not just vast but profoundly malleable. Time, which seemed so steady on Earth, is pliable here. It can stretch, slow, and almost stop. Gravity, motion, and mass work together in subtle, elegant ways to shape the passage of each instant. And yet, the black hole is not only a place of extreme gravity. It is also a window into the hidden structure of the cosmos. Around it, matter can swirl in a luminous disk called the accretion disk, heated to incredible temperatures as it spirals inward. Jets of energy may burst outward along magnetic field lines, stretching far into space, yet all the while time near the event horizon is bending slowly, invisibly, like a quiet river slowed by a hidden dam. From a safe distance, you can see how matter behaves, how light twists, and how the flow of moments itself begins to stretch in the grip of gravity. The black hole becomes a teacher, showing you how the universe can twist the very threads of existence. You reflect on all the journeys you've imagined so far, the traveling twin moving through space at incredible speed, satellites orbiting Earth with clocks ticking differently than ours, clocks near massive objects running slightly slower than clocks in empty space. All of these are gentle hints of the ultimate lesson: time is not absolute. It bends. It stretches. It flows differently depending on motion and gravity. And here, at the edge of a black hole, the lesson becomes almost tangible. The fabric of space-time itself is stretched to extremes. Moments that seem ordinary from afar are drawn out, elongated in ways that defy human intuition. And yet, the black hole is quiet. Its presence is formidable, but not violent unless you venture too close. It is a deep, still place where the universe reveals its most profound secret. Time and space are intertwined, malleable, and shaped by mass and motion in ways that are both gentle and extreme. You imagine drifting closer still, just at the edge of the event horizon. Time slows even more. Seconds become hours, minutes expand into eternity. If you were to hover here, watching the universe outside, distant galaxies would rush past like a river flowing too quickly to catch in your mind. And yet, inside your own frame of reference, you would move normally, feeling your heartbeat, breathing calmly, observing the silent ballet of stars and gas around the black hole. The universe becomes a place where the familiar rhythm of life, ticking clocks, passing days, flowing seconds, is no longer guaranteed. Where motion and gravity orchestrate the tempo of every moment. Here, you feel the edges of reality as if time itself is a pliable thread, stretched and shaped by forces both immense and invisible. And as you linger, suspended in thought at the boundary between the known and the unknowable, you sense the quiet enormity of what lies beyond. A place where time bends towards stillness, where space curves sharply, and where every journey through the cosmos is accompanied by the subtle, intimate rhythm of space-time itself. And in that suspended moment, you realize, what you have glimpsed is only the beginning of understanding how far the bending of time can go. Imagine now that you are even closer to the black hole. The dark sphere looms ahead, surrounded by the glowing halo of the accretion disk, its light twisting as it struggles to escape the immense gravity. You hover just at the threshold, at the edge of the event horizon, the invisible boundary beyond which nothing can return. The fabric of space-time here curves almost vertically. Time itself slows, stretching like a ribbon drawn taut by some invisible hand. From far away, any observer would see you moving slower and slower as you approach this edge. Tick. Pause. Tick. Seconds stretch outward, drawn by the black hole's immense gravity. The universe seems to move in slow motion. Galaxies drift, stars twinkle, and light bends around you in surreal patterns. And yet, inside your own experience, time flows normally. Your thoughts drift, your heartbeat remains steady, and each breath fills your lungs with familiar rhythm. It is only when compared to the outside world that time's extraordinary stretching becomes apparent. The closer you move to the event horizon, the more pronounced the effect. Light escaping from the black hole struggles against the immense pull, and the seconds outside your frame of reference rush past rapidly. From your distant friend's perspective, you appear almost frozen in time, hovering at the edge of eternity. Every gesture, every movement, is drawn out, elongated like a quiet symphony slowed to its softest tempo. The very idea that time can behave in this way is almost beyond comprehension. We are accustomed to thinking of moments as fixed, predictable, a steady tick-tock that marks our lives. But here, near a black hole, the steady rhythm dissolves. It stretches. It bends. It teeters on the boundary between movement and stillness. Even the flow of light itself seems altered. Photons struggle to escape the gravitational well, following curved paths that distort the familiar straight lines of space. The glow of the accretion disk swirls and dances, a luminous reminder that space-time is not flat, but a pliable, flexible surface shaped by mass. Gravity here is not gentle. It is absolute. It dominates the very fabric of reality, dictating how space curves, how light bends, and how time drifts. Yet there is a quiet beauty in this extremity. The black hole is not violent unless you cross the event horizon. It is a still place, an anchor around which the universe pivots. It teaches you about the limits of experience. It shows that time is not a universal constant, that every frame of reference carries its own unique flow. You might imagine a clock in your hand, ticking normally from your perspective. Yet an observer far away would see its hands nearly frozen, each second stretched toward eternity. It is a place where past, present, and future seem to whisper to one another, their boundaries softened by gravity's quiet insistence. And as you linger here, suspended on the edge, you begin to reflect on the nature of existence itself. How fragile our perception of time truly is. How dependent it is on motion, on mass, on the gentle or violent curves of space-time. You think of the satellites above Earth, their clocks slightly faster than yours on the ground. You recall the traveling twin, aging more slowly while their sibling remains on Earth. All of these are gentle hints of the deeper truth. time is a malleable river, flowing differently depending on your path through the universe. Here, at the edge of a black hole, that river almost pauses. You can sense it, a rhythm slowed to near stillness. And yet, it is not silence. It is not absence. It is the purest expression of the universe's hidden structure, a place where space and time entwine in ways that are almost impossible to imagine. Your mind drifts across the possibilities. If you could hover here indefinitely, which, practically, you cannot, you would experience time in a way no human has before. Years, decades, centuries might pass elsewhere in the universe, while you remain almost frozen, each heartbeat lingering, each thought unfolding in its own private tempo. And yet, there is no fear here. There is a strange serenity, a meditative clarity. The cosmos shows you its most profound secret without urgency. Time is not a straight arrow. It is a flexible thread, bending, stretching, and yielding under the influence of gravity and motion. Even the most massive objects cannot halt it completely, but they can slow it, fold it, and twist it in ways that reveal the underlying structure of reality. Imagine watching a distant galaxy while standing here. Its stars rush past, burning through millions of years in what feels like seconds to your distant observer. And you, suspended at the event horizon, are a quiet witness to the universe's vast rhythms, experiencing a moment that is both fleeting and eternal. The sensation is humbling. It reminds you that the universe is not a rigid, mechanical clock. It is a dynamic, living fabric. It bends, curves, stretches, and flows in response to mass and motion. And within this flowing structure, you find a sense of calm. Even as seconds stretch and moments linger, there is an order, a predictability in the patterns of bending space-time. You begin to understand that the cosmos operates with gentle rules, not chaos. Every curve has its measure, every tick its rhythm, even when that rhythm approaches stillness. And as you drift at this threshold, you realize that the edge of the black hole is also a threshold of understanding. A place where the familiar, comfortable flow of time is revealed as something fluid, responsive, and intimate. It teaches you that your perception of the universe is not absolute. That every frame of reference carries its own truth. And that in the extreme gravity near a black hole, these truths become most visible, most tangible. Yet even here, a quiet question lingers. If time can slow almost to nothing at the edge of this cosmic abyss, what does that reveal about the nature of the universe beyond? About the interplay of space, gravity, and motion? About the moments you have lived, and the moments yet to come? And in the gentle quiet that surrounds you, the black hole seems to answer not with words, but with the subtle stretching of time itself, inviting you to continue the journey, deeper into the mysteries of the cosmos, where time bends in ways still more profound. Imagine lying beneath a night sky, the stars stretching infinitely above you. You have journeyed far, drifting alongside a beam of light, racing with a twin through the cosmos, watching clocks bend near massive stars, hovering at the edge of a black hole. Each chapter of your journey has revealed a different rhythm of time, shaped by motion, gravity, and the very fabric of space-time. Yet now, as you return to the familiar earth beneath your feet, a quiet question remains. Why does time seem to flow at all? Why do moments progress from past to present to future, even when space and gravity can bend and stretch their rhythm? The answer begins not with motion or mass, but with the subtle, invisible patterns that govern the universe: entropy. Entropy is the measure of disorder, the gentle tendency of systems to drift from organization toward chaos. A tidy stack of papers gradually scatters, a drop of ink spreads through water, blending until its shape is lost. A warm cup of tea cools in the quiet air. These are small, everyday examples of a universal principle. Systems naturally evolve towards states that are more probable, more spread out, more diffuse, more entropic. And in this gentle, inevitable process, time finds its arrow. Moments flow forward because entropy increases. Your memories are stored in this forward-moving stream. Your body ages, experiences change, and the universe itself unfolds in one direction. Even though time can bend, stretch, and slow near massive objects or at incredible speeds, the arrow of entropy gives it a preferred direction. Imagine the universe as a vast, calm river. In most places, the water flows steadily forward, carrying leaves, dust, and light along its current. This current is subtle, invisible, yet undeniable. It is shaped by the gentle laws of thermodynamics, by the quiet insistence that energy disperses, that order evolves into complexity. And within this flow, everything unfolds. Stars form from clouds of gas and dust, live brilliant lives, and die, scattering their matter into the cosmos. Planets coalesce from the remnants, carrying with them the potential for life. Ecosystems evolve slowly on those planets, guided by the steady arrow of time. Even on the smallest scales, particles interact, decay, and transform in ways that obey the same principle. Entropy is not something to fear. It is the quiet rhythm that gives time meaning. It allows moments to be distinct, experiences to be sequential, and life to unfold in a coherent story. You might picture yourself as a leaf drifting along this river of time. You experience the gentle flow, carried forward by the increase of entropy, observing the universe as it moves ever onward. And yet, you also carry the knowledge of relativity, of bending time, of gravitational wells and moving clocks. Time is flexible. Time is personal. Time is a river that bends and swirls, yet still flows in one direction. The universe, it seems, is both fluid and directed, flexible and ordered. Consider your own body. You breathe. Your heart beats. Cells divide, grow, and decay. Each process obeys the gentle law of increasing entropy, carrying you forward through moments that cannot be reversed. And in this understanding, you sense the intimate connection between yourself and the cosmos. You are part of the universal flow of time, shaped by the same principles that guide stars and galaxies, particles and planets. Every choice, every movement, every heartbeat occurs within the current of entropy. It is both personal and cosmic, private and universal. Time, once a distant, abstract concept, becomes a living, breathing force. It carries you gently from moment to moment, weaving together the vastness of space, the pull of gravity, and the speed of light into one coherent rhythm. You begin to notice patterns everywhere. Morning turns to afternoon, afternoon to evening. Seasons change, leaves fall and regrow. Planets orbit stars. Stars live and die. Galaxies drift through the cosmos, their paths shaped by mass, motion, and gravity, yet all following the gentle direction of time. Even when time bends near black holes or stretches for moving travelers, the arrow of entropy points forward. It provides a quiet consistency, a subtle reassurance that the universe unfolds in a way that can be observed, understood, and felt. And as you drift in thought, you realize that the arrow of time is also a story, the story of change itself. It is the narrative of the universe, written not in words, but in the transformation of matter and energy. It is the gentle movement from simplicity to complexity, from order to disorder, from past to present to future. You can see it in the growth of trees, the evolution of life, the slow burn of stars, and the cooling of galaxies. It is the underlying melody that connects every experience, every motion, every moment. Time is not just a measurement. It is a story. A continuous unfolding of events, a quiet narrative in which the universe, and you within it, participate. And yet, even as the flow of entropy gives time its direction, there is still room for wonder. Because time is also flexible. It can bend, stretch, and slow in ways that reveal the subtle architecture of reality. It can flow differently for travelers moving at incredible speeds, or near massive objects that curve space-time. The universe is both structured and fluid, both predictable and mysterious. And you are a witness to all of it. Each second you experience is part of a cosmic current that stretches across space, shaped by mass, motion, and the quiet force of entropy. Every heartbeat, every breath, every thought is both personal and universal, a reflection of the river of time that carries all things forward. As you close your eyes beneath the night sky, you can feel the gentle rhythm of this flow. The stars above continue their silent dance. Galaxies drift through the cosmic ocean. And even here on Earth, beneath familiar skies, time carries you onward, bending softly in response to gravity, motion, and the ever-present arrow of entropy. You understand, at last, that time is a living story, woven from the threads of space-time and the gentle pull of change. It is a narrative without end, yet always immediate. And as you breathe in, feeling the quiet heartbeat of the universe, you sense that the story continues, unfolding in every moment, ready to carry you gently into the final chapter, where rest and reflection await. You lie back, letting your mind float freely through the universe, the stars scattered like tiny lanterns across the vast, dark expanse. The cosmic landscape stretches infinitely, yet somehow, you feel intimately connected to every point in space, every heartbeat of a distant star, every orbiting planet. Throughout your journey, you have witnessed time bend in countless ways. You traveled alongside light itself, feeling the curious stretching of moments. You watched twins age differently, depending on the speed of their journey through space. You observed satellites orbiting Earth, their clocks ticking differently than your own. You hovered near the edges of black holes, where time slows almost to a standstill. And now, as your mind drifts gently back toward home, you begin to notice a pattern. Time is everywhere, yet it flows differently depending on the shape of space-time, the pull of gravity, and the motion of matter. It is both universal and personal. It is a rhythm written into the cosmos, a melody that resonates quietly with your own heartbeat. Here, in this moment, you are resting inside that cosmic rhythm. The river of time flows softly around you, bending and curving in harmony with the universe, yet carrying your own present moments steadily forward. Imagine your body as a small clock within the larger cosmic clock. Your heart ticks, your breath flows, your thoughts drift all in tune with the gentle currents of space-time. Even as stars bend time with their mass, and black holes stretch it toward eternity, your own internal clock ticks calmly. It is a reminder that no matter how extreme the universe may be, your present moment is safe, gentle, and serene. The galaxies swirl, distant and luminous. Their light, traveling across millions of years, reaches your eyes softly, quietly, without urgency. You notice how the universe's bending of time and space is not violent or chaotic. It is a subtle shaping, a quiet modulation of rhythm that allows all things to move, change, and exist in harmony. The notion of past, present, and future blends gently, reminding you that the moments you experience are part of a larger cosmic narrative. Each tick of your heartbeat is echoed by the turning of planets, the orbit of stars, the slow expansion of the universe. And as you reflect on this, you feel a soft alignment between yourself and the cosmos. The universe does not rush. It does not demand. It flows. And so do you. Inhaling deeply, you sense the quiet motion of time through your body. Exhaling, you release tension, allowing your mind to float freely in this cosmic flow. You are both observer and participant, a conscious note in the melody of space-time. Even when time bends near massive objects or stretches near black holes, you remain present, anchored in your own awareness. The universe shapes the rhythm of moments, yet your inner clock continues to tick peacefully. You may imagine yourself drifting in the calm space between stars, weightless and serene, yet grounded in the gentle consistency of your own experience. The cosmos stretches around you. Light curves, galaxies rotate, and gravity shapes the fabric of space-time. And all the while, your own awareness rests calmly, attuned to the quiet beat of the universe. The lessons of your journey resonate softly in your mind. Time is not a rigid, unchanging line. It bends, stretches, and flows in response to motion, mass, and gravity. Yet despite all these variations, your own moment of awareness is steady, unbroken, and complete. Even as distant clocks tick differently, even as light slows or accelerates, you can rest. You can breathe. You can observe. You can be present. Imagine the gentle rhythm of space-time as a soft fabric, draping across the universe. Massive stars create subtle dips, black holes carve deep valleys, and planets weave gentle hills. And within these folds, your own life continues with a soft, steady pace. Time is no longer an abstract concept or an invisible ruler. It is a living, breathing presence, flowing through the cosmos and through you. As you drift in this awareness, you feel connected to everything, to the stars that bend time, to the satellites guiding navigation, to the light traveling across galaxies, to every heartbeat and breath you have ever experienced. The universe and your own consciousness resonate together in a quiet, harmonious rhythm. And in this harmony, you can find profound peace. There is no rush. There is no urgency. There is only the gentle, steady flow of moments, each one carrying you forward in the cosmic story. Your thoughts become softer. Your breathing slows. Your awareness drifts like a leaf on a calm river of space-time. You notice the gentle interplay of motion, gravity, and entropy shaping the universe. And yet, in the midst of these grand forces, you remain grounded, present, and serene. The black holes, the stars, the orbiting satellites, the flow of light across eons, all these cosmic movements continue, each in its own rhythm, each bending time in subtle and profound ways. And within this vast, interconnected clockwork, you rest. Time stretches and bends around you, yet your present moment remains a sanctuary, a gentle pause in the unfolding story of the cosmos. As your mind drifts towards sleep, you feel the quiet reassurance that even in a universe where time bends, curves, and flows differently everywhere. Your own now is always constant. You are resting within the cosmic clock. Each heartbeat, each breath, each thought aligns with the gentle rhythm of the universe. Time flows, moments unfold, and yet your presence remains steady, calm, and safe. And as your consciousness drifts, you feel the quiet joy of simply being, held in the vast, flexible, and gentle arms of space-time. Here, in this moment, you are home. The universe bends around you, and you rest fully, peacefully, eternally present. The journey through time has ended, and yet it continues, softly, gently, without rush, carrying you forward into the quiet, endless now.